In this video, I'm going to look at the last generation of Samsung Plasma TV. This is a 2013 model, and wow, have they changed. This one only has 3 boards in it, which is a huge reduction from the earlier models. This was brought to me by a customer, and he's already been into the set and changed the power supply, and guess what? It didn't fix it. What do you bet? It's the Y-Sustain buffer board. Let's take a look. Well, look what the cat dragged in. This set literally, it came to me in this condition, in pieces. It's a Samsung. This is a 2013 model. This one here is a, let's get a look at the model code on this thing. It's a 43AXYB02 panel, and you can see it's a Mexican made one. This is going to be one of the last of the plasma panels ever made, and the guy that owns this one's already tried to fix it. He replaced the power supply board. This is the original board. He's already bought a new board for it. Didn't fix it. Says the VS and the VA voltages are not working, but in fact they are. They're just shutting down. If I scope, or not scope, but if I put the meter on, you'll see when we first power the set up, the VS, first turn the set on, VS will come up to 209 volts and then it'll go off. So the set's going into shutdown. I suspect it's probably something here on the Y-Sustain board. What's a little different on this set that I'm not familiar with because I haven't seen one of these newer ones yet, but as you can see, what they've done on this is the X main is now part of the power supply, whereas the power supply used to sit in the middle on the Samsungs, and you had your X main or your Z sustain, as LG would call it, or your SS as Panasonic would call it, which is your common mode sustain. That's built right in. Here's the driver, the IGBTs are along here in your diodes. It's also got a main board. So they've basically reduced the board count down to 4 boards on this set. You've got your main signal board. You've got your address driver board that goes to the panel on the bottom. And on the left side here, you've got your Y buffer and Y-Sustain board is now in one unit. I suspect it's probably the Y-Sustain. So let's see if we can test this board and see if we have a shorted IC on here. So I'm going to pull the board out and we'll just test it with a meter and see whether there's anything that jumps out and says, I have a problem, Houston. It also should be pointed out, watch when I turn on the power. The health light here, which is supposed to flash about once a second, is flashing only once every 5 seconds. So that's telling us that there is a failure somewhere, and it's detecting that something's not communicating properly. So we can try reseating the ribbon cable. Sometimes these ribbons will come loose and cause problems. We can try reseating them. Usually it's a connection, or usually it's a component that's gone bad. One more connector here. No, set's not starting, so we'll take out the combination buffer and Y-Sustain board. To remove these connectors, you just flip the connector up as usual. Just flip them up like that, and then you can slide the ribbon cable out. You gotta be careful because if you damage these ribbons, these flexible cables, you've buggered up the panel. So take your time when you're undoing these and make sure that you don't tear them, because they are easy to damage. As I say, if you damage them, the panel is shot. So here's the procedure for testing your buffer chips. I know my other table looks like a disaster. Okay, so what we're going to do here is we're going to put the meter in diode test mode like it is now. And we're going to take our negative probe can't see my TV, so I hope I'm not in the shot. And we're going to put it on the out L, and we're going to measure to all of these pins on the chip. These measure the chips that go to the actual panel. So we're going to measure them all, and we're going to see about a 0.7 volt drop because we're measuring the semiconductors, the transistors basically inside each of these ICs, and we're just measuring a junction, and we're going to see about a 0.7, and that's normal. What we don't want to see is a short, right? Keep the probe on the L, and we can just drag along until we find, okay, that one's good, that's measuring these chips. The next one over. Again, we're okay. And get to the next one over here. Oh, 0.2. Okay, that's a problem, you see? We got to short this IC here. See that? Got a short on that IC. That's why the set's not starting. When the set does the self-test, it's testing all the ICs. And so this one IC, right there. There's your short. You can see it. That connector goes to this IC. So that IC shot, basically the whole board shot. And now I have to get back to the owner of the set and let him know that he ordered the wrong board. And this would have been such an easy fix had he gone in with a meter and tested before ordering any parts. But I hope you guys enjoyed this. This is a fast, quick video for this thing because when the owner of the set, if he decides he wants to fix this and gets me a new board, we'll put the board in and get the set back running. But I just wanted to get this one out there quick to show you guys how to troubleshoot one of these newer combination Y sustain and Y buffer board. Makes it simple because, you know, some of the other sets you could either have a bad buffer board or a bad sustain board or both, because sometimes when the buffer chips blow they take out the sustain board, and sometimes when the sustain board would blow it would take out a buffer board. At least on this design, you change the buffer, you change the whole board, you know that you've got the problem solved. Anyway, I just wanted to get this one out there quick for you guys so you guys could see this here. I'll let the owner of the set know the predicament. It's not actually his set, I think it's his neighbor's set. And I'll let him know and he can decide what he wants to do. But hey, we know what the problem is with this one. Thanks for watching. We'll catch you in the next one soon.